Okay, so on Friday we talked about multiplying these fractions. So today we're going to be talking about dividing those fractions. So back in the day, if you had something that looked like this right here, you were dividing it. So it looks kind of weird. So if we were to rewrite it, it's really a 3/4 divided by a 9/8. Now we talked about with multiplication, you're just multiplying straight across. And you guys brought up with division, there was the possibility of cross multiply. Now personally, I like to switch it to multiplication, which I think somebody also brought up. So if we switch it to multiplication, we keep the first fraction, change it to multiplication, and then we flip the second fraction. So it would become 8/9, and then we would do the exact same thing as when we multiplied, where we multiply straight across and we try to simplify as much as we can. So let's look at that with actual rational functions where we put that x into our equation. So let's look at this problem right here. So I'm going to first off rewrite it because I don't like when it looks like this. It looks kind of crazy. So we have 3x minus 3 over an x plus 7 divided by a 5x minus 5 over x plus 7. So to first start off, we are going to change it to multiplication. So I'm going to keep my first fraction exactly the same. I'm going to change to multiplication, and I'm going to flip my second fraction. So now that I have this as multiplication, I'm just going to do exactly what we did on Friday, and I'm going to look at each part of my fractions and see if there's anything that I can simplify or factor. So on the top, the 3x minus 3, it looks like I have a GCF. So I'm going to divide both of those by 3. So by doing that, divide this by 3 and this by 3. I'm going to pull that 3 out front. 3x divided by 3 is going to leave me with x. And negative 3 divided by 3 is going to leave me with a minus 1. On the bottom of that fraction, it looks like there's nothing I can take out, so it's just going to stay an x plus 7. Same thing over here, it's an x plus 7, which looky there, it's probably going to cancel. And on the bottom of this 5x minus 5, it looks like I can pull out a GCF also of a 5. So I'm going to do that. I'm going to pull that 5 out, which is going to leave me with an x minus 1. So by doing that factoring, I'm looking for the same thing on top and bottom of my fraction. I have an x plus 7 on top and bottom, so those x plus 7s can cancel, as well as I have x minus 1 on top and bottom, so those x minus 1s can also cancel. So all I'm left with on top is a 3, and all I'm left with on bottom is a 5. So I have simplified as much as I possibly can. And we also talked about saying what our x's cannot equal, saying that domain of our equation. So we had an x plus 7 on the bottom of our equation. So that means x cannot equal negative 7. Because if I were to set that equal to 0 and solve, it gives me that negative 7. Now I had this 5 on the bottom. If I set 5 equal to 0, there's no x to solve for, so it doesn't put a negative 5 or a positive 5 as part of my domain. It doesn't really tell me anything. And then I need to set x minus 1 equal to 0, which tells me that x cannot equal positive 1 as well. So I have my domain, what x cannot equal, and I simplified my fraction as much as I possibly could. So there's that slide if you need me to slide out a little bit or zoom out. All right, let's look at another problem. They already wrote it nicer than the last one, but we need to switch it to multiplication. So I'm going to keep my my first fraction exactly the same. I'm going to change it to multiplication, and I'm going to flip my second fraction. So that x squared plus 3x minus 4 is now on top. and x squared plus 5x plus 4 is now on bottom. So now that I have that, I'm going to factor or simplify as much of the fractions as I possibly can. So I'm going to look at one thing at a time. So on this first one, I'm multiplying to be positive 1, adding to be 2. So that looks like it would be, let me put my fractions, x plus 1 and x plus 1. Okay, on the bottom of that fraction, I'm multiplying to be a negative 1, but this one looks kind of weird. There's 0x in the middle, so I'm adding to be a 0x, multiplying to be a negative 1. So that would be an x plus 1 and an x minus 1, because 1 times negative 1 would be negative 1, and 1 plus negative 1 is 0. All right, up here now again, on the second fraction, multiplying to be negative 4, adding to be 3. So that would be a positive 4 and a negative 1. All right, last one to factor. We're multiplying to be a positive 4, adding to be 5. That would be positive 4 and positive 1. So now that we have everything factored, we're looking for what do we have on top and bottom that we can cancel out. So I see x plus 1 here and x plus 1 here on top and bottom. Those can cancel. As well as we have another x plus 1 on top and bottom. Those can also cancel. X plus 4 is on top and bottom. Those can cancel. Oh my gosh, and x minus 1 and x minus 1 are also gone. So everything canceled. Now when we talked about this on Friday, whenever something cancels completely on top or completely on bottom, that leaves us with 1s. So we have 1 on top since everything canceled and 1 on bottom since everything canceled. So 1 divided by 1 leaves us with an answer of just 1. Now we also need to say what our domain was. So anything that was on bottom, we set it equal to 0, and that gives us what x cannot equal. So on this one, if I set that x plus 1 equal to 0, it would tell me x cannot equal negative 1. If I set x minus 1 equal to 0, that would tell me x cannot equal positive 1. If I set x plus 4 equal to 0, it would tell me x cannot equal negative 4. And then this last one is x plus 1, which we already did, giving us x cannot equal negative 1. So we have our domain and we have our simplified fraction. All right, let's look at this one. So I'm going to rewrite it because I don't like when it looks like this. It looks kind of crazy. So we have 1 over x squared plus 6x plus 9 divided by x squared minus 6x plus 9 over x squared minus 9. Now with division, we're going to switch it to multiplication before we do anything. So I'm going to keep this first one the same. I'm going to multiply, and I'm going to flip my second fraction. So x squared minus 9 is on top now, and x squared minus 6x plus 9 is now on bottom. All right, so now that we have it in a multiplication, we are going to do as much factoring as we possibly can. So the top of that fraction on the first one is just 1, so there's really nothing to factor. Going to keep it the same. But the bottom, it looks like we're multiplying to be 9, adding to be 6. That's possible. X plus 3 and x plus 3. All right, going to the top of the second fraction, multiplying to be a -9, and there was 0x in the middle. So we're adding to be a 0x on this one. So that would give us x plus 3 and x minus 3. Lots of 3's on this one. All right, last but not least, we're multiplying to be +9, adding to be a -6. Careful with those positives and negatives. To be a +9 for multiplication, it would have to be 3 and 3, or -3 and -3. So to add to be that -6, it would have to be the -3 and the -3. So now that I have all of that factored, we're looking for the same thing on top and bottom. So I see x plus 3 is on top and bottom, and x minus 3 is on top and bottom, but I can't cancel both of them, just one. They have to match top and bottom. So it looks like nothing else can cancel. So I was left with a 1 on top, and on bottom we were left with an x plus 3 and an x minus 3. So that is as simplified as we possibly can get. But we also need to state our domain. What can x not equal? So if I set each thing equal to 0, that's going to give me my domain. Now make sure when you're doing that domain, you're going back to your original factored problem. Before you canceled anything, that is what you should be putting your domain as. So even if it canceled and it was on the bottom, it still gives you part of your domain. So the first factor, if I set x plus 3 equal to 0, that would tell me x cannot equal -3. Now this one is exactly the same. X plus 3 again is going to give me -3. I don't need to write it twice. If I take x minus 3 and set it equal to 0, it's going to tell me x cannot equal +3. And then this one is exactly the same. I don't need to write it again. So I have my fraction factored simplified as much as I can, and I stated my domain. All right, if you want to pause and try these two and then watch me do it, I would do that. The first one's multiplication, and the second one is division. Okay, now that you've tried them, let's take a look at the first one. We didn't need to do any flipping because it was already multiplication. So let's just start to factor. So I'm going to look at the top of that fraction. We were multiplying to be -8, adding to be a +2. So that should have been an x plus 4 and an x minus 2. On the bottom of that fraction, it was nothing to factor because it was just an x. So I'm going to leave it exactly the same. Looking at the top, it was multiplied to be a -36, and there was 0x in the middle. So we were adding to be a 0. So multiply to be -36, add to be 0 would be a +6 and a -6. All right, last one to factor. Multiply to be a -12. Add to be a +1 was hiding right there. So that would be a +4 and a -3. All right, so I factored everything. Now we got to look at what's the same on top and bottom. So I see x plus 4 is the same on top and bottom. And x minus 6 is the same on top and bottom. And that looks like everything. So we have our simplified as much as we can. So we're left with an x minus 2 and an x plus 6 on top and an x minus 3 on bottom. That is as simplified as it possibly could get. And then let's state our domain. X cannot equal, if I set x minus 6 equal to 0, it would tell me +6. I had to include that one even though it canceled because it was on bottom at one point. I also need to include this one even though it was canceled. So x plus 4 If I set that equal to 0, it would give me -4. And then last one, if I set x minus 3 equal to 0, it would give me a domain of +3. All right, moving to the next example. Here we go. We got to start off on this one by switching it to multiplication. So I'm going to keep the first one exactly the same before I even worry about factoring. I'm going to switch that to multiplication, and I'm going to flip my second fraction. All right, now that I have it in multiplication, I can just do it exactly the same by factoring. And it looks like, if I were to write out the top one, which I would do this, there's nothing really to factor, but to see if you can cancel anything, an 8, actually, 8, I would write out. What is 8 really? It is a 2 times a 2 times a 2. And an x squared is an x times x. Now I know that seems excessive to write that all out, but it can probably do a little canceling. If you have a GCF of a 2 on bottom, those 2's could cancel. So I would write that out as much as you can. All right, let's look at this next one. Multiply to be 12, add to be -7. That would be a -4 and a -3. All right, the top one is x minus 3. So there's really nothing I can do there, so I'm going to leave it the same. On the bottom one, it's not a normal factor, but there is a GCF. I can divide both of these numbers, 2 and 10. I can divide them both by 2. And they both have an x in them, so I'm going to take an x out. So I'm pulling out a 2x. Make sure you put it in the front. And that leaves me with x, and 10 divided by 2 is a 5, and there's no more x's left. So by doing that weird writing out of all of that multiples up here, I see I have a 2 on top and bottom, so those 2's can cancel, one of them, doesn't matter which one, and one of those x's can cancel. So that's why I wrote it out so weird, to make sure I notice all of the things that can cancel. I also see I have an x minus 3 on top and bottom, so I'm going to cancel those. And that looks like everything I can cancel. So let's see what I had left. I had a 2 times a 2 and an x on top. So really, a 2 times 2 means there's a 4x on top. Now that I'm done canceling, I can say it like that. I don't need to say 2 times 2 anymore. And on bottom, let's see, I had an x minus 4 left and an x plus 5 left. So that's everything that was left once we cancel. So let's also state that domain. What can x not equal? So we had this on bottom, so x minus 4, if I set that equal to 0, it would tell me +4. If I set x minus 3 equal to 0, it would tell me +3. Ooh, this next one's kind of funky, so let's actually set that equal to 0. If I set 2x equal to 0 and solved, I would divide each side by 2, giving me 0 divided by 2 is 0. So x cannot equal 0. And then last but not least, if I set x plus 5 equal to 0, it would give me a -5. So that's 4 different things x cannot equal. And we simplified as much as we possibly could. Great job. Try that worksheet that you guys got on Friday. It has division on the back of it. I'll collect that on Tuesday, and then we'll be moving on to 4.4 notes on Tuesday when we get back. Let me know if you have any questions via email or Canvas. I'll be checking it all day.